Hello everyone. I warmly welcome all of you to this lecture series on problem solving using C. This series has been specially designed according to the syllabus of first year BSc Computer Science students. Throughout this series, we will explore C programming language step by step, starting from the basic concept and gradually moving towards more advanced topic including array. The main objective of this series is not only to help you understand the C programming language, but also to develop your logical thinking and problem solving skill. Each topic will be explained in simple, practical and easy to understand manner with suitable example and programming demonstration. By the end of this course, you will have strong foundation in C programming that will help you in your examination as well as in your future programming course. Before we begin, let me introduce myself. My name is Mrs. Namita Amrutkar and I am working as an assistant professor at Abida Inamdar Senior College. It's my pleasure to guide you throughout this learning journey, and I hope this session will make programming enjoyable, interactive and easy to understand. So, without any further delay, let's begin today's session. Unit 1 is problem solving aspects. Now let us take a brief overview of Unit 1. Before we start writing a C program, it is important to understand how to solve a problem logically. This unit provides the foundation for developing good programming skill. As programmer, our first task is not to write a code but to understand the problem and design the correct solution. In this unit, we will cover five important topics. The first topic is Introduction to Problem Solving Using Computer. Here, we will learn what problem solving means, why computers are used to solve problems, and how programmers develop solutions for different type of problems. The second topic is Problem Solving Steps. We'll understand the systematic process of solving a problem, starting from and identifying the problem, analyzing it, designing a solution, implementing it, and finally testing the solution. The third topic is algorithm. An algorithm is a step-by-step procedure for solving problem. We will learn how to write clear, logical algorithm before writing any program. The fourth topic is flowchart. A flowchart is a graphical representation of algorithm using standard symbol. It helps us visualize the sequence of operation and make the logic easier to understand. Finally, we study compilation process. We will understand how a C program is converted from source code into executable program through different stages such as pre-processing, compilation, linking and execution. By the end of this unit, you will have a strong understanding of the complete problem solving process, which will help you to write efficient error-free C program. So let's begin with our first topic, Introduction to Problem Solving Using Computer. Now, let's begin with our first topic, Introduction to Problem Solving Using Computer. Before we learn programming, it is important to understand why computers are used to solve problems. A computer is a powerful electronic tools that help us solve a wide variety of problems quickly, accurately and efficiently. Today, computers are used in almost every field such as education, banking, healthcare, business, engineering and scientific research. Whether we are calculating marks, booking railway ticket, managing hospital record or processing online payment, computer help us perform these tasks faster and with fewer error than manual method. But simply having a computer is not enough. A computer cannot think or make decision on its own. It works only according to the instruction provided by the programmer. Therefore, before using a computer to solve a problem, we must first understand the problem clearly and decide how it can be solved. This process is called problem solving. Problem solving is the process of transferring a problem into a solution. It involves understanding the problem, analyzing the available information, selecting the appropriate strategy, and finally developing a correct solution. To solve any problem successfully, we use our knowledge, logical thinking, and suitable problem solving techniques. Let's understand this with simple example. Suppose a teacher wants calculate average mark of 50 students. Doing this calculation manually may take a lot of time and may also lead to mistake. Instead, we can write a computer program that accept the marks of all students, calculate the total, find the average and display the result within a few seconds. This show how computer makes problem solving easier, faster and more accurate. Now let's understand the role of programming. Programming is a problem solving activity. When we write a program, we are actually writing a set of instructions that tells computer exactly what to do and how to do it. These instructions written using programming language such as C. A good programmer does not start writing code immediately. First, the programmer understands the problem, plan the solution, and then write the program. This approach helps in developing efficient, accurate, and easy to maintain programs. So to summarize, we can say that a computer is a tool used to solve a problem, but it requires clear and logical instruction. Problem solving is the process of finding the best solution to a problem, and programming is the method of communicating that solution to the computer through a programming language. In the next topic, we will learn the step involved in problem solving which every programmer should follow before writing a program.
Using a computer as a problem solving tools, following steps are involved. First one, problem definition. Second one, problem analysis. Third one, coding. Fourth one, compilation and execution. Fifth one, debugging and testing. And the last one, documentation. We learn one by one. Problem definition. Computer programming requires us to define the problem first before we even try to create a solution. Problem analysis. Analyzing the problem requires us to identify the following: input, output, special constraint, any formula or equation to be used. Third one, coding. The code is written by program by using any programming language. C is called a source code or a source program. Fourth one, compilation and execution. The source code written in any programming language is not directly executed by the computer. It should be translated into a machine readable format, that is, actual machine language. The process of transformation of source code into a target code is called compilation. The converted program in actual machine language is then executed by the computer, which is known as program execution. The fifth step is debugging and testing. A written program may have error. Some error can be detected by the language compiler and some error cannot be identified with the compiler and occur during the program run. So testing is the process of checking the program by its correct functionality by executing the program with some input data set and observing the output of the program. Documentation. From the start of the problem solving to the end of the implementation of the program, all the tasks should be documented, that is, kept for future reference. Documentation may be of two types. Technical documentation is known as programmer documentation, which includes the problem analysis to implementation detail for that program. It is needed for the future reference for any modification, update of the program. User manual is the documentation prepared for the end user of the program that guides the user how to operate the program.
Now let's understand one of the most important concepts in programming, which is the algorithm. Before writing any computer program, we should always think about the step required to solve the problem. These steps are called as an algorithm. An algorithm is simply a set of instructions that must be followed for a computer to perform a calculation. These instructions are arranged in a correct sequence so that tasks can completed successfully. In simple words, an algorithm is like a recipe for cooking a food. Before preparing any dish, we first decide what ingredients are needed and what steps should be followed. If the steps are performed in the correct order, we get the desired result. Similarly, before writing a computer program, we prepare an algorithm that tells computer what to do. According to the formal definition, an algorithm is a finite set of instructions that carried out in a specific order to perform a particular task. These are few important words in this definition. The first word is finite. Finite means the algorithm must come to the end after limited number of steps. It should never continue forever. The second important word is instruction. Every steps in an algorithm should clearly tell what action need to be performed. There should not be any confusion or ambiguity. The third important point is specific order. The sequence of steps is very important. If the order is changed, the final result may become incorrect. For example, imagine you want to withdraw money from ATM. You first insert the ATM card, then enter the PIN, select the amount, and finally collect the cash. If you try to collect the cash before entering the PIN, it is impossible. Therefore, following the correct sequence is essential. Let's take another simple example. Suppose we want to calculate the area of triangle. The algorithm should start. Step number 1, start. Step number 2, read the length and breadth. Step number 3, calculate the area by multiplying length and breadth. Step number 4, display the area. And step number 5, stop. Notice that every step is simple, clear and arranged in the proper sequence. Now let's understand the characteristics of a good algorithm. A good algorithm should be have clear starting point and proper ending point. Every instruction should be easy to understand. The steps should not be repeated unnecessary. The algorithm always produce the correct output for the given input. It should always solve the problem efficiently without wasting time or resource. Algorithms are very useful because they help programmer think logically before writing the actual program. They reduce mistake and make coding much easier. When the problem is divided into a smaller steps, it becomes easier to understand and easier to convert into a programming language such as C. However, algorithms also have some disadvantages. Writing an algorithm for a very large and complex problem can take a lot of time. Sometimes, when the logic becomes complicated, the algorithm itself becomes lengthy and difficult to understand. Now that we understand what algorithm is, let us see how an algorithm is actually written using a simple example. Suppose we want to create a program that add two numbers entered by the user. Before writing the C program, we first create the algorithm. This helps us to organize our thought and ensure that every step is clear. Now learn about to add two numbers entered by the user. Step number 1, start. Every algorithm begins with the word start. This indicates the beginning of the process, just like every journey has a starting point. Every algorithm also needs a clearly defined beginning. Nothing is executed before the start statement. It simply tells us where the solution begins. Step number 2, declare variable a, comma b and sum. A variable is a name, memory, location used to store data. In this example, we need three variables. The first variable is a variable, which store the first number entered by the user. The second variable is b, which store the second number. The third variable is sum, which store the result after adding the two numbers. Before storing any value, this variable must be declared. This is why variable declaration come before taking input. For example, if the user enter 15 and 20, then A is equal to 15 and B is equal to 20. Some will later store the answer. Now the step number 3. Now the program asks the user to enter two numbers. Reading input means accepting data from the keyboard. Suppose the user enter first number 25, second number is 30. Now the computer store A is equal to 25, B is equal to 30. At this stage, the programmer has received all the information needed to perform calculation. Notice that until input is received, the computer cannot perform addition because it does not know what number it has to add. Step number 4. This is the most important step because this is where the actual processing takes place. The fourth step is add A and B and assign the result to sum. Here, the computer takes the value stored in A and the value stored in B, add them together and store the answer inside the variable sum. Now, the new variable sum store the result. This step is known as a processing. The computer is perform mathematical operation. Step number 5, display sum. After performing the calculation, the result should be shown to the user. This is called output. The computer displays the sum is, suppose A is 30 and B is 20, then sum is display 50. If we do not display the result, the user will never know whether the calculation was successful or not. Therefore, every program generally has three stages: input, processing, and then output. This simple example clearly demonstrates all three stages. And the last step is stop. Finally, the algorithm ends with the word stop statement. This tells the computer that all instructions have been completed successfully. Every good algorithm must have one start and one stop. Without stopping point, the algorithm continues unnecessarily. Now let's understand the computer algorithm using one practical example. Suppose you and your friend are counting number of books, your own. You have 18 books, your friend has 22 books. First, both values are noted down. Next, they are added together. Finally, the total number of books is announced. This is exactly what our algorithm does. It first accepts two values, then it processes those values, finally display the answer. This is why algorithms are often compared with everyday activities because both involve following steps in proper sequence. Now, let's understand the advantage of an algorithm. The first advantage is that algorithms are easy to understand. Since every instruction is done one after another in simple language, even beginner can easily follow the logic. The second advantage is that they provide step-by-step solution. Instead of trying to solve large problem at once, algorithm divides the problem into a smaller and manageable step. This makes problem solving much easier. The third advantage is that algorithm simply programming. Once the algorithm is ready, converting into a programming language such as C become much easier. The programmer already know what each step should do. The fourth advantage is that algorithm help in finding logical. Before writing the actual program, the programmer can examine every step and identify mistake in logic. Correcting mistake during the planning stage save lot of development time. The fifth advantage is that algorithm improve communication among programmer. When multiple programmers work on the same project, everyone can understand solution by reading algorithm before looking at the actual code. Although algorithms are very useful, they also have some disadvantage. The first disadvantage is that the writing algorithm takes times. For every small program, writing algorithm may seem like extra work. However, for large projects, the effort is worthwhile because it prevents many future errors. The second disadvantage is that complex algorithm becomes lengthy. When solving very large problem, the number of steps increase significantly. As the algorithm becomes longer, understanding and maintaining is also become more difficult. The third disadvantage is that algorithm cannot show the visual flow of execution. They only describe the solution using written steps. If you want to understand the overall flow quickly, then what to do? The new concept is developed which is called as a flowchart, which often more helpful because it presents same logic graphically. That's why programmer often use both algorithm and flowchart during software development. Before moving to the next topic, let's quickly summarize this slide. What is an algorithm? Algorithm is systematic sequence of steps used to solve a problem. In our example, we learn how to add two numbers using six simple steps: start, declare variable, read input, process the data, display the result, and stop. We also learn that algorithms are easy to understand, improve logical thinking, simplify programming, and help detect error before coding begins. At the same time, they can be time consuming to write and difficult to manage for every large and complex problem. Therefore, algorithms form the foundation of programming and are one of the most important tools used by every programmer before writing actual code. Let us move to the another important problem solving tool, the flowchart. A flowchart is a graphical or diagrammatical representation of an algorithm. Instead of writing the solution in the form of text or step, a flowchart uses different symbols connected by arrow to show how a program process work. In simple word, if an algorithm explains solution using written instruction, then a flowchart explains the same solution using picture and symbol. This makes the logic of a program much easier to understand. Think about traveling to a new place. If someone gives you return direction, you have to read every instruction carefully. But if they show you a map with arrow indicating route, you can understand the direction much faster. A flowchart work is exactly the same way. It represents the logic visually so that anyone can quickly understand the sequence of operation. Programmers use flowchart as a planning tool before writing the actual program. By preparing a flowchart, they can organize their idea, identify mistake, and improve the overall logic before coding begins. One of the biggest advantage of using flowchart is that it provides a clear picture of how data moves through the program. Every operation is presented using a standard symbol and arrow show the direction in which the program flows. Unlike the algorithm where we need every sentence to read every sentence, a flowchart allows us to understand the complete process by simply looking at the diagram. Now let's understand the important component of a flowchart. A flowchart is made up of symbol connected by arrow. Each symbol has a specific meaning. Programmers all over the world use the same standard symbol. The arrow indicate the direction in which the program executes. Therefore, while reading a flowchart, we always follow the arrow from beginning to the end. Let us study the basic symbol one by one. The first symbol is terminal. The terminal symbol represents start and end of the program. It usually drawn in an oval or rounded rectangle shape. Every flowchart must begin with start symbol and end with stop or end symbol. Without this symbol, we cannot identify where the process begins or where it finishes. Whenever to see the terminal symbol, remember that it represents the beginning or completion of the program. The next symbol is the process symbol. The process symbol is represented by a rectangle. This symbol is used whenever the computer performs some processing or calculation. For example, include adding a two number, calculating the average, find the largest value, assigning value to a variable, or performing any mathematical operation. The next symbol is input output symbol. This symbol is represented by parallelogram. It is used whenever the program accepts input from the user or display output on the screen. For example, asking the user to enter two number is an input operation. Displaying the sum on the monitor is an output operation. Since both an input and output involve communication between user and the computer, they use the same symbol. The next important symbol is decision symbol. The decision symbol is a diamond shape. A decision always check condition. The answer to the condition is generally either yes or no or true or false. For example, suppose we want to check whether a student has passed an examination. The condition may be the condition may be yes or no. Okay. Are the marks greater than or equal to 40? If the answer is yes, that program display pass. If the answer is no, the program display fail. Thus, whenever there is a condition or comparison in a program, we use the decision symbol. Next to is the flow line. A flow lines are arrow that connect different symbol. They indicate the direction in which the program moves from one step to another. Without the flow line, the symbol could not connect and we could not know order of execution. Therefore, arrows are very important because they show the logical flow of the program. Another useful symbol is connector. Sometimes a flowchart becomes very large and cannot fit on a single page. Instead of a drawing long arrow across the page, we use connector. A connector link one part of the flowchart to another part. This makes the diagram neat, organized and easy to read. Now let us understand how flowchart work with simple example. Now let's us understand the simple flowchart which show how to add two number using computer. A flowchart is a graphical representation of algorithm. Instead of writing the steps in words, we use standard symbol connected by arrow to show the sequence of operation. Flowchart help us to understand the logic of a program before we actually write the code. Let's go through the flowchart step by step. The first symbol is oval, which represents the start of the program. Every flowchart begins with a start symbol. It indicates where the program execution begins. Next, we have parallelogram, which is the input symbol. In this step, the program asks the user to enter two numbers, usually number 1 and number 2. These values are provided by the user through the keyboard to another input device. Since this step is taking input, we use the parallelogram symbol. After receiving the input, the flow moves to the rectangle, which is the process symbol. This symbol is used whenever the program performs calculation or processing. Here the operation sum is equal to number 1 plus number 2. This means that the program adds the two input values and stores the result in another variable called sum. Once the calculation is complete, the flows move to another parallelogram, which is used for output. In these steps, the program display the calculated value of sum on the screen. This allows the user to see the result of the addition. Finally, the flow reaches the oval symbol, which represents the end of the program. This indicates that all required steps have been completed successfully and the program terminates. So, we summarize the flowchart. The sequence is very simple. Start, input two numbers, add the numbers, display the sum, and end. This example may seem very simple, but it demonstrates the basic structure of every computer program. Most programs follow the same pattern. They accept input process, the data, produce the output, and then terminate. Before writing any C program, creating a flowchart like this help programmer visualize the solution, identify mistake and understand the logic more clearly. It also makes debugging and explaining the program much easier. Now, let's understand another example of flowchart. This flowchart is used to check whether a given number is even or odd. This example introduces an important concept in programming called decision making. Unlike the previous example, where the program simply follows a sequence of steps, here the program has to make decision based on a condition. Let's understand flowchart step by step. The flowchart begins with start symbol represented by an oval. Every flowchart starts with this symbol, indicates the beginning of the program. Next, we move to the input symbol, which is parallelogram. In this step, the user enter a number This number is stored in a variable called as a number. After taking the input, the flow reaches the most important symbol in this flowchart, the decision symbol, represented by diamond. The condition inside the diamond is number mod 2 is equal to 0. Here, percentage operator is called modulus operator. It returns the remainder after dividing one number by another. For example, if the number is 10, then 10 mod 2 is equal to 0 because 10 is exactly divisible by 2. If the number is 15, then 15 divided by 2 is equal to 1 because the remainder is 1. The decision check whether the remainder is equal to 0. If the answer is yes, it means the number is divisible by 2 without leaving any remainder. Therefore, the program follow the yes branch and display even number. If the answer is no, it means the remainder is not 0. In that case, the program follow no branch and display odd number. After displaying the result, both paths join together and the program reaches the end symbol, indicate the execution is complete. So the complete sequence of this flowchart is start, input number, check whether number mod 2 is equal to 0. If yes, display even number, otherwise display odd number and end. This example demonstrates how decision making work in programming. The program choose one of the two different paths depending on whether the condition is true or false. We'll notice that many real life applications use similar decision making logic. For example, checking whether a student has passed or failed, determining whether a person is eligible to vote, or verify whether a password is correct. All involve making decision based on certain condition. In C programming, we implement this type of logic using decision making statement such as if statement and the if else statement, which we'll study in detail in the upcoming units. This flowchart gives us clear visual understanding how a computer makes decision while executing a program. So far in this unit, we have studied algorithm and flowchart separately. We learned that both are problem solving tools used before writing a computer program. Now important question arises. If both help in solve a problem, then what is the difference between them? In this slide, we learn compare algorithm and flowchart point by point. Understanding this difference is important because question comparing algorithm and flowchart are frequently asked in examination. Let's begin with the first difference. Meaning, an algorithm is a step-by-step written procedure for solving a problem, while flowchart is another hand graphical or pictorial representation of that procedure. In simple word, algorithm explain the solution using sentence, whereas flowchart explain the same solution using symbol and arrow. For example, if you want to prepare tea, an algorithm would list the steps such as boil water, add tea leaves, add milk, add sugar, and serve. A flowchart would represent this same step using symbol connected by arrow. So the logic remain the same, only method of representation change. The second, representation of the solution. The next difference is the way of solution is presented. In algorithm, solution is written as a number steps. For example, step 1 start, step 2 read two numbers, add the numbers, next steps display the result, last step stop. Everything written in step text. In flowchart, the same solution is present using symbol such as start symbol, input symbol, process symbol, output symbol, and symbol. Therefore, algorithms are text-based, whereas flowchart is diagram-based. Third, ease of understanding. Algorithm requires reader to carefully read every instruction. Though the steps are simple, understanding long algorithm can sometimes take time. Flowcharts are usually easier to understand because the entire process is shown visually. Our brain often understands picture more quickly than paragraph of text. For this reason, beginner generally find flowchart easier than algorithm. Fourth one is debugging. Another important difference is debugging. Debugging means identifying and correcting logical error. In an algorithm, every step is written clearly because the instructions are listed one after another. It is often easier to locate logical mistake. For example, if calculation step appear before the input step, we can easily notice the error. In a flowchart, debugging may be slightly difficult because we have to several symbol and arrow. If the flowchart is large, following every path can take more time. Therefore, algorithms generally consider more convenient for checking logical error. Form of representation. Algorithms use simple English or natural language. They do not require special symbol. Anyone who understands language can easily read algorithm. Flowchart, however, use standardized graphical symbol. Every symbol has a fixed meaning. The whole, for example, a whole represents start end, parallelogram represents input output. Because these symbols are internationally accepted, program across the world can understand a flowchart without language barrier. Sixth one, solving complex problem. When large problem, very large problem, algorithm are generally easier to write because we simply keep adding more steps. Although the algorithm become longer, it remains structured. Flowchart become difficult to manage when the problem become very large. Too many arrows, decision boxes, and connector can make the diagram confusing. Therefore, algorithms are usually preferred for representation very complex logic, while the flowchart are better suited for small and medium sized problem. Time required. The final difference is the time required for preparation. Writing algorithm usually takes more time because every instruction has to be written carefully. The programmer has to think about each step and express it clearly. A flowchart can often prepare more quickly for simple problem because symbol and arrow communicate the logic visually. However, very large system, both algorithm and flowchart require carefully planning. Now let's understand with practical example. Suppose we want to calculate area of rectangle. Using algorithm we have right steps. Read length and breadth, calculate area, display the area and stop. Now let's think about the same problem using flowchart. We begin with start symbol, then use input symbol, next use process symbol, then use output symbol, finally use the end symbol. Both methods solve exactly the same problem. The only difference that one uses written steps and another uses graphical symbol. So which one is better? The answer is both are useful. Algorithm are better when we want to describe the logic in words or explain complex problems step by step. Flowchart are better when we want to understand the sequence of operation quickly through visual diagram. Then we can say that both are important tools in problem solving and learning. Both help us become better programmer. So far, we have learned how to solve problem using algorithm and flowchart. After planning the solution, the next step is to write the program in programming language such as C. But here is an important question arises. Can the computer directly understand the C program that we write? The answer is no. Although C language is easy to human being to read and write, but computer cannot understand it directly. A computer understands only machine language, which consists of binary digit zeros and ones. Therefore, we need a translator that converts a C program into a machine language. This translator is called as a compiler. A compiler is a special software program that translates the entire source code written in a high level programming language into a machine code before the program is executed. In simple word, we can say that a compiler acts like a translator between the programmer and the computer. Let's understand this is real-time example. Imagine that an Indian tourist visits Japan but does not know Japanese language. Similarly, a Japanese person may not understand English or Hindi. To communicate, they need a translator who listens in one language and convert into another language. In the same way, the programmer write instruction in C language, but the computer understand only machine language. The compiler act as a translator between them. Now let's understand some important terms. The program written by the programmer in C language is called as a source code. This is the code that we type in editors such as CodeBlock, Turbo C, or Visual Studio Code. Since it is written in a programming language, human can easily read and understand it. However, the CPU cannot execute source code directly. The compiler read the entire source code. The compiler read entire source code and convert into another form which is called as a machine code or a object code. This is the this is the language understood by the processor. After successfully compilation, the object code is used to create an executable program which can then be run on the computer. Let's understand complete process step by step. First, the program write the C program. This program is called as a source program. Next, the compiler read the entire source code from the beginning to end. It check whether the program follow all the rules of the C language. For example, it check whether the semicolon are present, whether variable are declared correctly, whether bracket are properly matched, and whether the syntax is correct. If the compiler find any error, it display error messages. The programmer then correct those error and compile the program again. Only when the source code is completely free from syntax error does the compiler generate object code. This object code is then used to create executable file that can be finally run. One important feature of the compiler is that it translates the entire program at once. It does not execute the program line by line. Instead, it first checks the complete program and then generate machine code. This makes compile program execute much faster because the translation work has already been completed before execution begins. Now let's understand advantage of using compiler. First one is high execution speed. Once the program is compiled, the computer executes the machine code directly. Since no translation is required during execution, compiled program run very quickly. The second advantage is efficient performance. Because the compiler performs many optimization during compilation, the final executable program is often faster and more efficient. The third advantage is error reporting. Before generating machine code, the compiler checks the entire program for syntax error. If mistakes are found, it displays list of errors so that programmer can correct them. Although this may seem time consuming initially, but it helps improve the quality of the program. Now let's understand few limitations. Whenever changes are made to the source code, the entire program must be compiled again. This takes additional time, especially for large software projects. Another limitation is that executable file generated by compiler is usually platform specific. For example, a program compiled for Windows may not run directly on Linux unless it is compiled again for that operating system. Now let's understand all these things in simple example. Suppose we write a C program to add two numbers. The source code maybe contains statement like declare two variable, accept two number, add them, display the result. Although these instructions are meaningful to us, the CPU cannot understand them. The compiler translates this instruction to machine language. After translation, the processor executes the binary instruction and display the answer on the screen. This entire process happens within a few seconds. As a program usually do not see the machine code because the compiler performs the translation automatically. Before end this slide, let's summarize the important points. What is my compiler? A compiler is a software program that translates the entire source code into a machine code before execution. The programmer writes the source code in C language and the compiler converts it into a object code. Compiler check the entire program for syntax error, report mistake and generate executable file only when the program is correct. Because the translation is completed before execution, compiled programs are generally fast and efficient. In the next slide, we will study another translator which is called as an interpreter and compare how it works differently from a compiler. In the previous slide, we learned about the compiler. We saw that a compiler translates the entire source code into machine language before execution. Now let's study another type of language translation called as an interpreter. Like a compiler, interpreter is also a software program that helps the computer understand program written in high-level language. However, the way it works completely different. An interpreter translates and executes the program one line at a time. This is the most important point to remember. Compiler translates the entire program first, whereas interpreter translates one statement at a time and immediately execute it. Let's understand with simple example. Suppose you have written C program containing 10 statements. If a compiler is used to read all 10 statements, check the entire program for errors and then convert the complete program into a machine code. But if an interpreter is used, it starts with the first statement. It translates the first statement into machine language and immediately execute it. Then it moves to the second statement, translate it and execute it. This process continues line by line until the program is finished. Now imagine that the interpreter reaches the fifth statement and find an error. What will happen? The interpreter immediately stop execution. It displays the error message and wait for the programmer to correct the mistake. After correcting the error, the program must be executed again from the beginning. This is the one of the main characteristic of the interpreter. It does not continue execution after finding the error. Instead, it stops exactly at the line where the errors occur. This makes finding and correcting mistake much easier because the programmer know the exact location of the error. Let us understand this thing in a real life example. Imagine that a teacher is reading a story to a class. After reading each sentence, the teacher explains its meaning before moving to the next sentence. If a student asks a question about the third sentence, the teacher stop, answer the question, and then continue. This is similar to the how interpreter work. It processes one statement at a time. Now compare this with the compiler. A compiler is like a translating the entire book first and then giving the translated book to the teacher. The compiler translation is prepared before anyone start reading it. This simple example helps us remember the difference between compiler and interpreter. Now let's discuss the advantage of an interpreter. The first advantage is easy error detection. Since the interpreter check one line at a time, it immediately tells the programmer where the error has occurred. This makes debugging simple, especially for beginner who is learning first time. The second advantage is no separate executable file is required. The interpreter directly executes each statement after translating it. This allows programmer to quickly test small piece of code without waiting for the entire program to compile. Another advantage of faster program development. Since the programmer can execute and test code immediately after writing it, they can quickly identify mistake and make correction. This is the one reason why interpreter languages are popular for learning and rapid application development. Now let's discuss disadvantages. The biggest disadvantage is slower execution. Why execution slower? Because every time the programmer runs, the interpreter has to translate each statement again. Unlike a compiler, it does not create machine code that can be reused. As a result, the translation process happens repeatedly during execution. These increase the total execution time. Another disadvantage is that the programmers stop immediately if an error is found. Suppose there are 20 statements in the program. If an error occurs at fifth statement, the remaining 15 statements are not executed. The programmer must first correct the error and then execute the program again. This is helpful for the debugging, but it also interprets the execution of the program. Now let understand consider practical example. Suppose we write a simple program to calculate average of three number. The interpreter start with the first statement. It translate and execute the variable declaration. Next is translate execution the input statement. Then it process the calculation. Finally display the result. If there is a syntax error in the calculation statement, the interpreter immediately stop at that line and report the errors. The remaining statements are not executed until the mistake is correct. Many popular programming languages use interpreter. Python, JavaScript are interpreted languages or use interpreter-based execution environment. These languages are widely used because they allow programmers to write, test, and modify code quickly. This is especially useful during the software development, web development, automation, and data science. Now let's study another important component of the compilation process called linker. Many students think that once the compiler finishes, it works the program ready to execute. However, that is not always true. After compilation, another important step takes place and this step is performed by the linker. So the what exactly linker is? A linker is a special system program that combine one or more object file along with the required library files to create single executable program. In simple words, the compiler translates a source code into object code, but that object code may still be incomplete. The linker completes the program by connecting all the required parts together. Let's understand this with simple real life example. Imagine you are building a house. Different workers prepare different parts of the house. One team build the walls, another team install the door, another team install the window, another team complete the electrical wiring. Each team finishes its own work, but the house is not ready until all these parts connected together. The person who combine everything into one complete house is similar to the linker. The linker takes all the separately prepared parts and join them together to create one complete executable program. Now let's understand how this works in C programming. Suppose you write C program that uses printf function. Did you write the code for printf yourself? The answer is no. The printf function is already written by the C language developer and stored inside a library. Your program only calls the function. When the compiler compiles your source code, it recognizes the printf being used, but the actual code of printf is stored somewhere else. The linker searches the standard C library, find the required code for printf and connect it with your program. Without these steps, the program would not know how to execute printf function. This is why the linker is so important. Now let's understand all this process step by step. First, the programmer write the source code. Next, the compiler converts source code into object code. At this stage, object code may still contain references to library function such as printf, scanf, square root. The linker then searches these functions in the appropriate libraries. Once the required functions are found, the linker combines them with the object code. Finally, generate a complete executable file, usually having the .exe extension in window. This executable file is now ready to run. One important responsibility of the linker is combining multiple object files. Large software projects are rarely written in single file. Different programmers often work on different modules. For example, one programmer develop login module, another develop payment module, a third develop report generation module. Each module is compiled separately. producing different object file. The linker combine all these object file into a one file. Without the linker, these separate modules could never work together. So far, we have studied three important components of the compilation process: the compiler, interpreter, and linker. Now we learn about the final stage of this process, which is loader. The loader is the last steps before program actually start running. Let's first understand what loader is. A loader is a special system program that loads the executable file created by the linker into the computer's main memory, also known as a RAM, and prepare it for execution by the CPU. In simple words, the compiler translates the program, linker create the executable file, and the loader places the executable file into a memory so the processor can execute it. Without the loader, even a perfectly compiled program cannot run because the CPU can only execute programs that are present in the main memory. Let's understand this is the real life example. Imagine you have written a report and save it on laptop hard disk. The report is stored safely, but simply storing it on the hard disk does not mean you are working on it. When you double click the file, the operating system open it and load into a RAM. Only then you can read or edit it. Similarly, an executable program may exist on the hard disk, but before it can run, it must first be loaded into a RAM. This important task is performed by the loader. Now let's understand the complete process step by step. First, the program write the source code. Next, the compiler convert it into object code. Then linker combine object files and library files to create an executable program. Finally, when the user run the program, the loader load that executable file into a RAM. Once the program is loaded into memory, the CPU begins executing its instruction. This completes the entire compilation process. Now let's discuss major responsibility of the loader. The first responsibility, loading the program into memory. The executable file is stored on a secondary storage such as hard disks. The loader copies this executable file into a computer's main memory. Only after this transfer can processor execute the program. The second responsibility loader is memory allocation. Every program requires memory to store variable, instruction, and temporary data. The loader allocates sufficient memory space for the program before execution begins. Without proper memory allocation, the program cannot function correctly. The third responsibility is preparing the program for execution. After loading the program into memory, loader perform necessary initialization. It ensures that the program start executing from the correct entry point, usually the main function in a C program. Once everything is ready, control is transferred to the CPU and program execution begins. Suppose you have written a C program to calculate factorial of a given number. You save the program and compile it. The compiler convert into object code. The linker create an executable file named, for example, factorial.exe. Now you double click the executable file. At this moment, the loader start working. It read the executable file from the hard disk. It load the program into a RAM. It allocate memory for variable. It prepare the execution environment. Finally, it hands control to the CPU. The process now start executing the instruction one by one and the program display the output. Notice that all of this happen with a fraction of a second. Most users never realize the loader is working behind the scene. However, it is an essential part of the operating system. Now you understand each component has a different responsibility, but together they ensure that a program written by the programmer can be successfully executed by the computer. One simple way to remember the compilation process is this sequence. First one, write the C program. Second one, compile it, third one link, fourth one load, and last one is execute. This sequence represents complete journey of C program from source code to the execution. Now let's quickly compare the compiler and interpreter. Both are language translator that convert high level programming language into machine language, but they work different way. Compiler translate the entire program at once before execution. If there are errors, it report that error after checking the whole program. Once the program is successfully compiled, it creates executable file and the program runs much faster because no further translation is needed during execution. Interpreters, on the other hand, translate and execute the program one statement at a time. It finds the error if it immediately stop that line and display the error message. This makes debugging easier, especially for beginner. Another important difference is the speed. Compiled program execute faster because the translation is completed beforehand. Interpreter program are generally slower because translation happens time consuming. A compiler usually requires more memory since it generates executable file, whereas interpreter uses less memory because it directly executes the translated statement without creating a separate executable. In terms of development, interpreters are convenient for testing and debugging because errors are identified line by line. Compilers are prefer developing large applications where fast execution and better performance are required. With this, we have completed the topic of compilation process. Thank you everyone. Today we learned the complete programming process including problem solving, algorithm, flowchart and the compilation process. These concepts are the foundation of C programming and help us to develop logical and efficient programs. I hope this session was helpful and informative. Thank you.